Hello, my name is Anagha, and I will be presenting my project on the topic of multilingual sentiment analysis investigating perceptions of globalization. The two languages spoken in the most number of countries in the world are English and French. English is spoken as the official language in 55 countries and French in 29 countries. The two languages achieved this geographical spread through colonization, and as a result, the speakers of these languages harbor many insightful and often conflicting perspectives surrounding topics such as culture, human rights, and economic instability. These topics intersect with the subject of globalization and form crucial contributors to an individual's perspective on this subject. Globalization has been trending steadily upwards since the 1970s and has become a subject of hot debate in recent years, with influences of globalization reaching out to impact trends in production and labor markets, advances in technology, and climate change, all of which are expected to significantly influence and shape our future. It thus stands to reason that understanding these trends and predicting future trends becomes a topic of great relevance. As humans, we express our sentiments through language, but languages are not just tools of communication, they shape how we see the world. They carry culture, history, and unique perspectives. Today, a vast amount of communication happens over the internet. Social media platforms are frequently used to express thoughts and beliefs on various topics and enable users to act under anonymity if they wish, increasing candor and revealing true opinions. The vast amount of unstructured data generated on these sites can be leveraged to gain insights on the sentiments and beliefs upheld by our societies on important topics like globalization. Traditional graph convolutional networks have proven to be an effective tool for aspect-based sentiment analysis. It considers the dependencies between text elements encoded as a graph to extract information that informs sentiments. The Sentic graph convolutional network is a model particularly suited to the fine-grained task of aspect-level sentiment analysis. It works by integrating common sense knowledge into the framework of graph convolutional networks to take advantage of both syntactic dependencies and the underlying knowledge that encodes meaningful information. This feature of incorporation of language-specific common sense knowledge in the Sentic GCN model motivates the reasoning behind the hypothesis of this project. The key hypothesis being that an instance of the Sentic GCN trained on one language is able to model the syntactic and common sense knowledge specific to that language. As a result, when classifying a new dataset that is translated into this language, it will misclassify those data points that are heavily informed by the culture specific to the speakers of the source language of the new dataset. This leads me to the objectives of this project. The first being to develop and analyze a corpus containing comments and opinions on the topic of globalization posted to social media sites in two languages, French and English. The second key objective is to extract culture-informed sentiments and analyze the trends in these sentiments. I will now describe in further detail the methodology that was used to achieve each of these objectives. Firstly, the corpus was formed through data collection. With over 70 million daily active users, Reddit stands out as a social media site on which a large amount of text-based content is produced, making it a relevant source of data for this project. To create a comprehensive dataset that is representative of the English-speaking world as a whole, a list of subreddits focusing on a diverse range of topics was retrieved. Two search keywords corresponding to two different spellings of the word globalization were used to retrieve relevant entries from each of the subreddits. The English dataset had a total of 2,770 entries. In order to retrieve posts and comments relevant to the topic of globalization originally posted by users in French, 4 different translations of the keyword globalization were used as the key search terms and were similarly applied to a comprehensive list of French subreddits. The final French dataset consisted of a total of 626 entries. In order to carry out an investigation on the perceptions on a multilingual paradigm, it was required that the two final collated datasets, one in French and the other in English, each be translated to the other language. The Microsoft Azure AI translator service was chosen for this purpose due to its speed, security, and reliability. Following this methodology, 2 further collated translated datasets were obtained. Next, the data labeling was carried out using the SenticNet API. The SenticNet polarity classification algorithm can return two possible labels, positive and negative. This was combined with the intensity ranking algorithm, which was used to identify entries corresponding to low intensity, to which the label of neutral was assigned. For the entries with intensity higher than 25, the polarity classification algorithm is run on the text to get a resulting label of positive or negative. Prior to beginning model training, three different graphs are generated for each of the train and validation sets: a dependency graph, a Sentic graph, and a combined Sentic dependency graph. The first is an ordinary dependency graph, which captures the syntactic information of the given sentence using the aspect word, that is, globalization, to separate the sentence into three subtexts. An adjacency matrix is generated where the nodes are tokens and the edges connect each token to its syntactic children and vice versa. The adjacency matrix is used to create the bidirectional unweighted graph representation of each sentence. The combined Sentic dependency graph makes use of SenticNet knowledge base, which contains a dictionary of words mapped to their corresponding affective score. It combines this affective knowledge as well as the syntactic information contained in the sentence to encode both dependencies between the tokens as well as the relative importances of the tokens by assigning weights based on the relative importances of the two tokens connected by an edge. The aspect token is assigned an additional weight of 1 to represent its relative high importance. Due to the nature of this project, the task of aspect extraction was unnecessary, which removed the inaccuracy in this dimension. Instead, the aspect of each sentence was determined to be the word that was searched to obtain the data point, that is, the word globalization and its variants, including synonyms and translations. From each sentence, the aspect word was extracted and replaced with a string of special characters used by the model to identify the aspect position in the sentence, around which the sentence is broken up for graph construction. For the training, the Sentic GCN uses a standard gradient descent algorithm to update parameters, while optimizing by minimizing cross-entropy loss. The Sentic GCN model takes in a number of arguments that can be specified while running the training command. In order to obtain the best possible model with the highest predictive capability, the different combinations of hyperparameters were tested by developing a script that automated the hyperparameter specification in the train command. The corresponding maximum average test F1 and accuracy were recorded as evaluation metrics. Following the training of the models to obtain the model with the best performance, it was applied on the translated dataset of the opposite language to obtain the corresponding predicted labels. The model trained on the French dataset was used to predict the labels for the dataset of English entries translated into French and vice versa. Following the key hypothesis, the next step was the extraction of the culture-specific sub-dataset in each language. The predictions of the model were compared against the true labels generated by the language-specific SenticNet API, and the misclassified data points were extracted, and the original untranslated text forms the two culture-specific sub-datasets. This leads me to the next section where I will detail the results of the investigation. A total of over 3,000 variants of the Sentic GCN model were trained, and their corresponding maximum average test F1 and accuracy scores were recorded. The impact of each of the hyperparameters on the resulting F1 were analyzed for each of the models. This led to the identification of the best performing model for each of the two languages. The two best performing models had the following evaluation metrics, with F1 scores of around 66% and accuracy of 72% for the English model and 64% for the French model. Following the identification of the best models, the analysis of the trends in the misclassified subsets found that the subset of data points that are influenced heavily by those aspects of culture or common sense knowledge that is specific to each language are skewed more negatively in terms of polarity, whereas those data points that are culturally common to both languages are skewed more positively. The two extracted datasets were then fed into the Sentic API to identify the resulting trends. Firstly, the task of intensity ranking was performed. The distributions of the two datasets show that the English culturally influenced dataset had higher intensity on average. In contrast, the French culturally influenced dataset has relatively higher spread, but the majority of the data points are also concentrated at relatively high intensity. Comparing the trends in the results of the toxicity spotting model, it can be observed that the English culture-specific dataset shows a relatively lower level of toxicity on average. However, the two datasets are similar in that the vast majority of data points have toxicity of 0, with relatively even distribution over the other values. We can infer that the data that is exclusive to both cultures contains text expressing sentiments that are by and large not harmful, although a minority of the data points do show high toxicity. With regards to the well-being assessment task, the dataset of French culture-specific data points showed lower well-being with a negative median value representing higher stress levels in these authors. Only a few outliers in the French dataset correspond to high well-being. In contrast, the dataset of English culture-specific data showed comparatively higher well-being. The median is greater than 0, showing that a significant number of data points have authors with positive well-being. Next, the class distributions of the generated labels for the personality detection task were analyzed, and the vast majority of entries in both datasets fall into the class ENTJ, which is the personality type characterized by assertiveness and confidence. There were, however, little significant differences in the assigned class percentages when comparing between the two datasets. To conclude, a novel methodology of extraction of culture-specific text data in English and French was proposed and implemented. This methodology involved making use of the affective common sense knowledge extraction framework of the Sentic graph convolutional network by training in a target language and testing the source text after conversion through machine translation into the target language. The misclassifications by the target language model on the translated text were hypothesized to be attributed to cultural common sense knowledge differences due to the syntactic similarities between the two tested languages. Future work on the topic could include applying the methodology on a larger data set of text posts, which would ideally result in improvement of the accuracy of the two trained models. The size of the French dataset undoubtedly contributed towards the unsatisfactory performance of the trained French model, so sourcing a larger dataset in the French language would be beneficial to obtain a model with higher predictive capability. Additionally, efforts to manually annotate the datasets for polarity would serve to solidify the legitimacy of the findings. That brings me to the end of my presentation. Thank you for your attention.